This video will cover the key points and requirements when preparing for a practical chemistry examination. Before the examination, ensure complete syllabus coverage and a practical approach to teaching. Focus on the objectives, content mastery, paper layout, and learner participation, including evaluations. Observations are changes seen during an experiment. These include color changes, formation of precipitates, gases evolved, noting color and smell, and the production of sound, heat, or light. Only test for gases if one is known to be produced or if instructed. Gases can be detected by color, effervescence, smell, and their effect on moist litmus or dichromate paper. Deductions or inferences state something about the unknown substances. They can identify anions and cations, whether a substance is an oxidizing or reducing agent, or if an organic substance is saturated or unsaturated. Deductions must be specific, like stating Cu2 plus present, not just Cu2 plus. Write deductions immediately after observations, even for tests showing no precipitate. Do not defer all deductions until the end. The 6 commonly tested areas in Paper 3 are volumetric analysis, qualitative analysis, inorganic and organic, flame tests, solubility and solubility curves, reaction rates, and enthalpy changes. In inorganic qualitative analysis, cation identification uses reagents like sodium hydroxide, aqueous ammonia, soluble chlorides, and soluble sulfates. Prepare small quantities of solution using dilute acids for insoluble substances. The addition of NaOH solution yields different precipitates and color changes, providing clues to the presence of specific cations like Na+, K+, NH4+, Ca2+, Mg2+, Pb2+, Al3+, Zn2+, Fe2+, and Fe3+. Adding aqueous ammonia also helps identify cations. Observations like no white precipitate, a white precipitate insoluble in excess, or a green or brown precipitate correspond to the presence of specific ions. The addition of soluble chlorides or sulfates can identify ions. A white precipitate with dilute hydrochloric acid or sodium chloride indicates Pb2+ or Ag+ ions. With dilute sulfuric acid or sodium sulfate, it suggests Ca2+, Pb2+, or Ba2+. The flame test identifies cations based on the color produced. Lilac or purple flame means K+, golden yellow is Na+, crimson is Li+, brick red is Ca2+, and green-blue is Cu2+. Anion identification involves various tests. For example, adding dilute acid and observing effervescence suggests CO32 or hydrogen carbonate dash. Other tests include using barium chloride, barium nitrate, or lead-2 nitrate solutions. For organic qualitative analysis, the common identification reagents are flame tests, halogens like bromine water, oxidizing agents, pH, carbonates or hydrogen carbonates, and esterification, which involves alkanol or alkanoic acid. To determine solubility and solubility curves, you're given a solid A and required to find its solubility at different temperatures following the procedure of heating and cooling the solution while observing crystallization. Table 1 displays the volume of water, temperature at which crystals appear, and the calculated solubility of solid A in grams per 100 grams of water. The graph shows solubility curves for various salts, like KNO3, K2SO4, sodium chloride, and copper-2 sulfate, illustrating how their solubility changes with temperature. In volumetric analysis or titration, marks are awarded for completing the table, correct decimal places, accuracy, principle of averaging, and final accuracy, totaling 4 marks. Notes for volumetric analysis cover handling strange values, consequential marking, rounding off, alternative methods, and correct use of units. For reaction rates, practicals often test factors like concentration and temperature. You may be required to determine the reaction rate between an oxidizing and reducing agent using provided solutions. The procedure for reaction rates involves measuring solutions, mixing components, and timing the appearance of a visible change, like a blue color. Finally, calculate the rate as 1 over time. Another reaction rate experiment requires determining the rate between acidified potassium manganate, 7, and aqueous glucose at different temperatures. This involves heating the mixture and recording the time and temperature for the color change from purple to colorless. Enthalpy changes experiments require determining the enthalpy change for a reaction, such as between a solid A and hydrochloric acid. Procedure A involves mixing the substances and recording temperature changes over time. Plotting a temperature time graph for the enthalpy change experiment helps determine the maximum temperature change, delta T, which is essential for calculations. The images display examples of typical enthalpy change setups and corresponding graph plots for experimental data. To find the molar heat of displacement of copper by iron, mix aqueous copper 2 sulfate with iron powder. Record the temperature change over time while stirring the mixture. The temperature time data collected during the displacement reaction experiment is plotted on a graph to determine the temperature change. This slide provides examples of the type of questions asked in the examination, focusing on calculations related to heat of reaction and volume determination. The image highlights calculations, including finding the mass of a substance, moles, heat change, and molar heat of displacement. Common areas in theory exams include correcting errors in setups, separation of mixtures, uses of substances, and redox reactions. Pay attention to marking requirements and suggested revision. In defining terms, all definitions must be exact. Avoid working definitions. Distinguish between terms by defining each one separately. Key areas in the periodic table include chemical families, trends in physical properties, changes in bond type and structure across period 3, writing compound formulas, and writing equations. Regarding bonding, remember to include how the bond is formed. Explaining a hydrogen bond must clarify that it is an additional bond, not the main or only bond in a substance. Salts cover preparation methods and properties, including solubility and action of heat. Conductivity of substances relates to the flow of electrons. When dealing with carbon, nitrogen, sulfur, chlorine, and their compounds, focus on gas preparation, apparatus setups, and industrial processes. Gas laws and other principles must be stated exactly, including factors to be kept constant. Ensure you cover stating, explanation, graphical representation, and application through calculations. When asked to name a substance, provide the name and avoid the formula. For identification, you can use either the name or the formula.